Marhaba. Okay, recall that one of the main objectives of this course is to train you how to write down, how to construct a mathematical proof. And how do we write down proofs? We write them using logic. And remember that logic has two parts, a precise language and a collection or a list of deduction rules. Okay, these deduction rules are also called rules of inference. So previously we talked about propositional logic and predicate logic, and in these sections we learned how to write statements in logic using predicates, propositions, logical connectives, and quantifiers. So this practice of writing statements in propositional logic or predicate logic is the precise language of logic. This is the first part. Today we want to learn about the second part of logic, which is the rules of inference or deduction rules. Okay, we use these together, the language of logic, together with the rules to write proofs. And what are proofs? They are what we call valid arguments. So today we want to talk about what is an argument and when an argument is valid. And we will start this video with this example. Okay, so suppose you have, I want to say that this is an argument. It is composed of three sentences. The first two sentences say, if you have a student card, then you can enter the campus. The second sentence says, you have a student card. And then therefore we deduce, since you have a student card, and if you have a student card, then you can enter the campus, we can deduce that indeed you can enter the campus. Okay, so this is the argument. We call these two, the first two, which are the information we have, that this is say a university rule which says if you have a card you enter the campus, and the second information we know that you have a student card. So we call these the premises of the argument. Okay, and we call this one, the last one, what we deduced, the conclusion. Okay, and we want to say that this is a valid argument. So this whole thing, the premises together with the conclusion, is called an argument. And we want to say that this is a valid argument because whenever the premises hold, whenever they are true, so suppose the university has a rule which says if you have a card, a student card, you can enter the campus. So suppose this is true. And suppose also that you have a card. So suppose the premises are true, then you can enter the campus. Then the conclusion is true. Okay, so this is the idea in which we will define an argument to be valid by saying when an argument is valid, whenever its premises are true, then its conclusion must be true. Okay, so let me write all of these concepts in a formal way. And we want to work in propositional logic for now. So you can think of statement one as, so we can, you have a student card. Let me use another color. So you have a student card, we can call it the proposition P. You can enter the campus, this is Q. You have a student card. Okay, you have a student card, this is P as well. And you can enter the campus, this is Q. See, let's look at what is the logical form of this argument. The first statement is P implies Q. Right, this is a conditional statement, if then. The second one is just P. And then therefore, if P implies Q is true, and P is true, then we conclude that Q must be true. Okay, so this is the form, the logical form of the argument above. And we say this is an argument, and moreover, it's a valid argument. Why it again we call it valid because whenever this is true and this is true, it must be that the conclusion Q is true. Okay, do you want to see this? Let's see why this is the case. Suppose P implies Q is true. Suppose the whole thing is true. And suppose P, the hypothesis of the conditional statement, is true. Now Q is a proposition. It could be true or false. If it were false, then true implies false is false. But we know that the whole conditional statement is true. So Q can't be false. It must be true. Okay, that's why this is a valid argument. Okay, now let me discuss all of these notions in a formal way. So let's say definition. An argument, what do we mean by an argument? An argument in propositional logic is simply a sequence of compound propositions. Let me say, so this is the first compound proposition, alpha 1, alpha 2, alpha 3, and so on, up to alpha n, and we want to call the last proposition beta. So this is what is an argument. Simply, it's just a list of propositions. Now, all of them except the last one are called the premises of the argument, and the last one, beta, is called the conclusion of the argument. So in this example, we have alpha 1, alpha 2, and beta. So this argument is a sequence. It is alpha 1, alpha 2, and beta, where alpha 1 is P implies Q, alpha 2 is P, and beta is Q. Okay, so as simple as that. An argument is simply a list of propositions, and we just call all of these, all the alphas, premises, and the last one we call it a conclusion. So this is the first point of the definition. The second point is, when do we call an argument valid? So the argument above, okay, this argument is valid is valid. So now we want to define validity of arguments if whenever all the premises are true, all the premises of the argument, whenever all of alpha 1, alpha 2 up to alpha n are true, all of them are true, then the conclusion must be true. Then beta must be true. Okay, so here we don't care about the case when some, of course, the alpha, say alpha 2 could be true or false. We only care about the case when all of them are true. So suppose we only consider this scenario when alpha 1 is true, when alpha 2 is true, when alpha 3 is true, when alpha n is true. We want to see that when all of them are true, it follows that the conclusion has a truth value. Okay, so to show that an argument is valid, you assume that all the premises are true, and then you show that the conclusion must be true. Okay, I hope this rings a bell. Remember that we said a conditional statement is a tautology, is always true if whenever its hypothesis is true, its conclusion is also true. So I want to use this to say validity in a different way. So an argument is valid if, look, whenever all the premises are true. This means that whenever alpha 1 and alpha 2, so I take the conjunction of all the premises, implying the conclusion beta. So now I get a conditional statement. Okay, so we get a conditional statement. Its hypothesis is the conjunction of all the premises. Okay, so this is one proposition. It is the conjunction of all premises. So and beta is the conclusion. Now, I want to say an argument is valid means that this conditional statement, whose hypothesis is the conjunction of all the premises and its conclusion is the conclusion of the argument, is a tautology. Okay, so I'm saying again that an argument is valid means that whenever the premises are true, the conclusion must be true. But this is the same as saying that this conditional statement is a tautology. You see, let me explain why. Suppose this conditional statement is a tautology. We know that if this is a tautology, it means that whenever the hypothesis is true, the conclusion is true. So suppose the hypothesis is true, but the hypothesis is a conjunction of all the alpha i's. And for it to be true, it means that each one of them is true. Okay, so this is true, this is true, this is true. So whenever each one of them is true, then beta has to be true. So exactly this is what we wrote here. Let me do it in, highlight it in pink. It's this one. Whenever all of them are true, then beta, the conclusion, is true. This is the same as saying that this conditional statement is a tautology. And it means this is a tautology. It means that whatever you substitute truth values for the propositional variables inside each alpha I and beta, you always get a true value. Or when you construct the truth table of this one, you get true always. Okay. Now what we want to do is take examples of valid arguments, and these they will be short valid arguments, so very short sequence, and these ones we will call them rules of inference. Okay, let's see what is the first rule of inference. We have already seen it. It's called modus. We have already seen it. It's called modus ponens, and it has this form that the first premise says P implies Q, the second premise says P, and the conclusion we say therefore Q. And we've seen that this is valid because whenever this is true, so suppose this is true and this is true, it follows that Q must be true. So this is a valid argument. Or you can check that the conjunction of the premises implying the conclusion is a tautology. So check the following, that P implies Q, this is the first premise, take it in conjunction with the second premise P, all of them implying the conclusion, show that this is a tautology. That is always true. Okay, let's do it together. So here is P, here is Q. We have four cases here: true, 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 false, false, true, and false, false. Okay, what do we have here? We have P implies Q. What's P implies Q? It is true. This is the only place where it is false, and then true, true. Then we want to take the conjunction of P implies Q, conjunction P. So I'm talking about the first column and the third column. True and true is true, true and false is false, false and false. Now let's look at this implying Q. So P implies Q and P all implying Q. So I want to look at this column implying this column. Okay, so let's see. True implies true is true. Okay, false implies false is true. false implies true is true, and false implies false is true. See, we got a tautology true, 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 true. Okay. So this is a short valid argument. It has two premises and it has one conclusion. Since it's a valid argument, it's short, we call it a rule of inference, and it has the name modus ponens. Okay, let's take another rule of inference. It's called modus tollens. Okay, and modus tollens says that if the first premise in your argument is P implies Q and the second is not Q, then you can conclude that not P is true. Okay, so this is a valid argument, which means whenever these are true, whenever they are true, it follows that not P is true. Okay, now do you want to see this? Suppose, okay, again, suppose P implies Q is true, so the whole conditional statement is true. Suppose not Q is true. If not Q is true, then Q is false, so Q is false. Now, what can you tell about P? P either it is true or false. Okay, suppose it is true. If P is true, then true implies false is false, but we know the whole thing is true, so P must be false, which means that not P is true. This is one way to show that this is valid. Again, an argument is valid if whenever the premises are true, the conclusion follows to be true. Okay, the other way is to show that the conjunction of the premises, what is the conjunction of the premises? P implies Q is the first premise, and the second premise, not Q, all implying the conclusion, show that this whole thing is a tautology. So construct its truth table and show it's always true. Okay. Now let me tell you the third law, rule of inference, hypothetical syllogism. Okay, it says that if P implies Q is true and Q implies R is true, so these are the two premises, then we can conclude that P implies R is true. Again, you need to see that this is valid, assume these are true, and show this whole thing must be true. Or construct the truth table of the conjunction of the premises implying the conclusion. So P implies Q and Q implies R, all implying the conclusion, which is P implies R, show that this whole thing is a tautology. Because if you show that this is a tautology, this means that whenever the hypothesis is true, which means whenever this is true and this is true, it follows that the conclusion is true. Okay, now let me go to the lecture notes and continue the rules of inference from there. So we've seen the modus ponens, it has this form, and now this is the modus tollens and the hypothetical syllogism. Now the next one is called disjunctive syllogism. It says it has two premises and one conclusion. It says if P or Q is true and not P is true, then Q must be true. Okay, why is this? Now if P or Q is true, this means either P is true or Q is true. But by the second premise, we know that not P is true. If not P is true, this means that P is false. And since P or Q is true, it must be that Q is true. So we can conclude Q. So again, disjunctive syllogism says if you know P or Q is true and you know not P is true, which means P is false, then you know that Q must be true. So you can deduce that Q must be true. Okay, let's see the addition rule. If you know that P is true, then you can conclude P or Q is true. Okay, why this is valid? Because whenever the premises are true, the conclusion is true as well. What is the? We only have one premise here, which is P. If P is true, then P or anything else is also true. Because for a disjunction to be true, we need at least one true. Okay, the simplification rule. Suppose that P and Q is true. We can conclude P is true. Why is this? Because if P and Q is true, by definition of conjunction, we know that P is true and Q is true. So we can conclude P is true. Now, so one way to show this is a valid argument is to show whenever the premises are true, the conclusion is true. When P and Q is true, this means that P is true. Okay, or you can show that the premise implying the conclusion is a tautology. So construct the truth table of this conditional statement and see it's a tautology. Now the conjunction rule, what does it say? It says suppose P is true and Q is true. So you have two statements and both of them are true. These are the premises. Then you can conclude that P and Q is true. Okay, now this is obvious, as if P is true and Q is true, then P and Q is true because the conjunction is declared to be true when both are true. The other method, the other way to show it's a valid argument is to show that the conjunction of the premises, so P and Q, implying the conclusion, which is P and Q, this conditional statement is a tautology. Okay, and finally the last rule is the resolution rule. It says if your first premise is P or Q and second premise is not P or R, okay, this suppose both are true, then you need to show that Q or R must be true. So which means either Q is true or R is true. So this is an exercise. Either convince yourself that whenever 1 is true and 2 is true, the conclusion must be true, or show that the conjunction of the premises, so the first premise and the second premise implying the conclusion, is a tautology. These are the rules of inference, of propositional logic.